All right, welcome everybody to week 12, day 2. Today we're going to go over really how to interact with a game world in code. So before we've been doing this all in blueprints, today I'm going to be showing you how to do it in code, specifically in Quake, because that will probably be useful for your Quake mod project. If you are doing Quake mod, you don't have to. And so the good news is there's only a few different ways that programs really interact with a game world. And once you understand these few tools, there's just 5 of them. You can basically program any game using combinations of these tools. And if you have knowledge of things like linear algebra with dot product and cross product, then you do even more stuff as well. So let's just go through them. So one of the first things you can do in your code to interact with the world is to make a new object in it. It's called spawning an object. So for example, when you click the mouse button and a rocket appears, you have spawned a rocket into the world. It's a pretty obvious way. And then you can give that new spawned actor, they're called entities in QuakeC, they're called actors in Unreal Engine. You can then give them a velocity and set them free into the world. And the most common thing we do with new spawned projectiles is we just turn them loose, give them velocity, usually in the direction we're looking, times the speed. And when they touch something, then we call a function. So we do something called having a callback or an event handler on the rocket or the nail or whatever projectile you've created. So basically, all it takes in code is you click, you spawn a new nail or projectile or something, you give it a velocity in the direction you're looking times its speed, and you say when this thing hits something, call this other function. And typically you also give it a second thing, which is like a timeout duration. So if it doesn't hit anything in 5 seconds, 10 seconds, then erase it from the world so you don't clutter the world with too many things. And that's it. That's a projectile weapon. I'll give you code examples and in-game world examples of these things as well. In fact, let me just show you right now. So if we come over here and just go into the scout, you can see that the textures are missing on that. Interesting. But when I click, you can see that that kickback is just really annoying. That it's firing a nail, and the projectile travels through the world until it hits something. And when it hits something, it plays a little flash, and that's about it. If it hit a player, then the thing would do damage. Okay. Okay, so that is spawning an actor and touch. So let me show you what that looks like in code. If I come over to my code directory over here. Hang on one second, my DoorDash just arrived. All right, back. Sorry, I have to clear my DoorDash immediately because there's a cat in the neighborhood that has learned that DoorDash equals food and will go and steal my food off my porch. So I have to like immediately jet over there and save my burrito or whatever. I've posted photos on Discord. The cat will just sit there and just watch. Like when there's any car idling in front of my house, it just runs up and just watches. I've got on my security cameras coming up and opening things with its mouth, purring to itself. Okay, so how do we spawn an actor? Okay, so we know how to do this in Unreal. It is simply the spawn actor function, right? In fact, I've got a comparison here we can go through that I've made a little cheat sheet that shows you how to do the same things in Unreal Engine and QuakeC. So for example, spawning entity is called spawn in QuakeC. It's called spawn actor in Unreal Engine. You'll see that basically everything that can be done in one can be done in the other. Like there's a few things that Unreal can do, usually in like the visual effects, like it's got volumetric fog and it's got skeletal animation, even though Quake has skeletal animation now. They patch it in. The fans patch it in, not the official release. Cool, lighting effects and all the, the UMG stuff. Like all that Quake can do. But like as far as like the actual components of making a game, yeah, you can spawn entity, you can do a trace line, all that kind of stuff. And I've got a cheat sheet that I'll post for you guys on that. So let me just show you the code over here on how to spawn something. So over here. Right click, open in code, and Pavlovian conditioning. I know it's a smart cat, but man, that thing drives me crazy. All right, so like fire nail. I don't know. Like how do we, again, how do we find these things, right? So nothing. Okay, let's search for a nail gun. That's probably going to turn up some things. So there's all these hits here, and we're looking for an equal sign because this is QuakeC, right? So probably down in weapons.qc, new missile weapon, damage nail gun. So there it is. So the name of the function is not fire nail, it's called launch spike. Okay, and it is given this function here is given an origin, that's a point in space, and it's given a direction that is the direction the nail is going to come out. Okay, and so that's how you do it right there. Boom. That creates a new object in the world, and by default it is empty. It has no model, it has no velocity. It is essentially, for all intents and purposes, invisible and non-functional. So we set the owner to ourselves so that when it kills somebody, we get credit for the kill. We set its move type so that the physics are basically it flies without gravity, right? You saw the nails just fly very unrealistically through the air. It is a solid bounding box, so it's got a little box and that can touch something. Vector angles dir gives us a dir is the direction the nail is going to come out, and this is the rotation of the nail gun in world space. And then here we have where the magic happens. Okay, so when you want to make a projectile weapon in code, what you do is you create the projectile, give it a velocity, which is going to be down here. Yeah, there it is. There's the velocity. But you make it so that when it touches something, there's a callback. Okay, and all you pass it is a function name. So the name of the function is called spike touch, and a lot of times these things are around here, but not always. There it is, super spike touch. Launch direct spike, super spikes, spike touch right there. Yeah, I just scrolled around. I could have controlled F for it too, but they're usually in the same area. And so you can see that when it touches something, then it does stuff, right? So if it hits the sky, it deletes itself. If it hits a player, it's going to do like 12 damage, I guess. Yeah, if other class name is player, TFT damage, whiz damage. So if we're a wizard spikes, that's from a monster. So basically, I think we're going to do like something like 12 damage, per hit. And so we do 12 damage when we touch something, and then it removes itself. That's basically, if you want to simplify this whole thing down, when the nail touches something, it damages the other person for 12 points and deletes itself. And then there's a lot of other stuff in here for like doing that little flash, the little spark when it hits something. That's this code here. This is like the Niagara system, except it's extremely limited. But this is the particle effect system in Quake. It doesn't really matter right now. And the rest of the stuff is just, your typical error checking. If it hits the sky, it would look really weird having a spark play, so it just deletes itself without a spark, that kind of stuff. But essentially, what we do when we make a spike is a nail, is we just spawn it. We give it a location, which is right here. We give it a size. We give it a model so that it appears in the world. We give it a velocity. We give it a touch so that when it touches something, it calls that function. And then we also give it a think. And so a think is the next thing I'm going to talk about. And so that basically says in 6 seconds, delete myself. So right here, next think is time plus 6. So the current time is always in a global variable called time. Time plus 6 is 6 seconds from now. So what this code here says, if the nail doesn't hit anything in 6 seconds, then it calls this function instead. And the remove function just deletes the thing out of existence. Very simple. So every object in the world has a touch and a think. And that's basically all you really need to make even the most, complicated of projectile weapons, really. So it's coming back into my notes here. Okay. So you spawn an actor, you set a touch on it, turn it loose, and then when it touches something, it does damage. Okay. Second thing is think. And so every object in the world, if you set its think member variable, there's a dot think on it, or dot next think. If you set that, then when the game time exceeds that value, then it calls whatever function is in the think variable there. So this is what it looks like. You set the next think to be time plus 6. So that means in 6 seconds. and then you set the function that gets called. In 6 seconds, call this function. And so you can have, this is a very simple example. You can have something like a grenade that or a missile that every frame updates the direction it's traveling to follow a laser dot, that kind of stuff. In fact, I have code for that in here. I wrote it myself. You can have AI that every half second wakes up, looks around, and goes, nope, nobody's here, and it goes back to sleep for half a second. Then it wakes up again, looks around, goes back to sleep. So what you do with that kind of stuff is how you implement that. Like if you want to have a periodic timer kind of thing, what you do is you have the thing set its next think to time plus half a second, 0.05. And then its think be, check to see if enemies are nearby. And then in half a second it calls that, and then the thing wakes up, does some trace lines or something. Nope, nothing's visible. Then it sets its next think again to time plus 0.05. And then it just, every time you call the function sets its next think to the current time plus 0.05. And so basically what you get is a repeating event. Every half a second, it wakes up, looks around, there's nobody there, it goes back to sleep. And so you can use think and next think to actually create very complicated AI behaviors and things like that, where once it's actively attacking somebody, you can think more often. When it's been asleep for a while, you could even have it only wake up every so often, every 3 seconds maybe, and look around. Sleep again. Like it could be literally sleeping, and it just very periodically wakes up and looks around, goes back to sleep. But usually that's more metaphorical. Most AI guards aren't sitting there every frame doing these very expensive calculations. They typically periodically will check to see if something is visible to them. And so with think and next think, you can program like all sorts of really, really interesting behaviors. Between touch and think, you basically can do all sorts of really cool, crazy stuff. Next tool is traceline. And so traceline is called line trace in Unreal Engine. The same thing, it's just the words are backwards. I don't know why. So traceline means you give it a starting location, you give it an ending location. Starting location here, ending location here. These are X, Y, Z values, and it draws a line through the world. And how this works is the topic we talk about in IS50B. In IS50B, we actually talk about how you implement game engines and things like that. For now, all you need to know is that it's expensive, but it's not that expensive. It's slightly expensive. Okay. And the game is designed to accelerate those kinds of things, where you can say, shoot a gun, and the start of the bullet is here at the end of your gun, and the ending point is the direction you're looking times the range on the gun, and it will draw an invisible line through the world, and when it hits something, it'll tell you there was a hit there. And it's exactly the same thing as an Unreal Engine, just it's going to look a little bit different in the code. Okay, you guys understand? Start point, end point, shoot a line, shoot a ray through the world until it hits a wall or something, right? So we come over here and I don't know, get a salt cannon. Why not? So when you shoot, it's gonna do a ton of trace lines through the world, and every time it hits a place, it draws a little spark and a little dust cloud there. Yeah. So this is like repeatedly, like it is repeatedly doing trace lines, like every frame, like just spraying bullets out, Yeah. That makes sense to y'all? So you don't have to do just one. You can have it do 12 at once. And there's a question of cost, right? Like you don't necessarily want to do that. But, for something really cool like the assault cannon, like, yeah, it may be worth it. There's probably not too many people using the assault cannon at any one time. So, we live in a science fiction future. Like you can handle 12 trace lines every so often. So. Yep, guns are usually done with trace lines, or they're done with projectiles. Or if you really want to be fancy, like if you're doing like one of the Sniper Elite games where it simulates bullet drop and things like that, it doesn't technically have to be a line. You can actually do some sort of like hyperbolic path through the world to simulate wind and gravity and stuff like that for most video games is just complete overkill. You know what I mean? Like when you're playing Valorant, like who here plays Valorant? I don't play it, so I actually don't know. But do they have like the effective wind on bullets in Valorant, or you know, like bullet drop over half a mile? I don't play it either. Yeah, so I don't know. I would be surprised. I would be pleasantly surprised if they simulated the effective wind, you know, on the bullets in the game. But it's usually not the kind of thing that most game developers worry about. Mario Golf, yeah, yeah. Like so in a golf game, like yeah, or if you're if you're doing like a sailing game, a lot of times wind matters, you know. So Black Flag doesn't. Like in Black Flag, you can sail directly into the wind; it doesn't matter in the slightest. But for most games that are trying to be at least somewhat, you know, realistic, like you can't sail a sailing ship directly into the wind, right? So you know they'll have a wind direction, and you sail faster, and you have to tack into the wind and stuff like that. Arma 3 does it. Ballistic system. That's cool. That's cool. Usually that's one of those trade-offs between realism and fun, right? Like more arcadey video games like Quake, the bullets just travel straight. The nails travel straight. They fly. There's no gravity on them. But if you want more of a realistic, gritty military simulator, then bullets will like penetrate through walls and have bullet drop and wind and stuff like that. Like, so humidity in the air. Yeah. Okay. So let me show you how traceline works in Quake. Okay. So, right, you just click, and then it's doing a series of trace lines from your gun outwards. And if you notice, you can see there's some random scatter. You guys see that? Like the bullets aren't coming out directly straight. It's actually randomly jittering around, and so the bullets are kind of coming out in kind of a cone pattern. And this is actually one of the things that I did was I actually changed the assault cannon to make it a little bit more interesting. So there's actually two different cones that it scatters in. There's actually a tighter cone and there's a wider cone. By default, the assault cannon was so inaccurate, like it came out like this, and so bullets are like coming out sideways almost. And so what I did was I actually have half the bullets coming out in kind of a tighter spread and half of them coming out in a wider spread. And so that has an effect of like rewarding people for aiming, you know, so if you can point your crosshair at the person, you do more damage. But also it made the assault cannon not suck, right? Because if you're shooting at somebody like, you know, just like where that wall is, and your bullets are going like this, like you're not doing any damage to them. So you really have to like be up in their face to hurt them. And if you're if you're a heavy weapons guy, you can't move fast. So the weapon was actually really bad. You know, it was actually a really bad weapon to have. It was maybe good for like quarters and things like that, where you can kind of do area denial, but it was actually a really bad weapon. So let me show you how to do also a random vector there. They make actual military applications. That makes sense. Yeah. I've actually worked on military sims before. And I've looked at doing like grants and things like that for the military, working on like realistic kinds of stuff. Yeah, it's different from game development, right? It's different. So let's see here. Let's see if we can find the assault cannon. Light assault. Assault cannon. Let's be under weapons.qc. Bullet trace line. Okay. So this is fire bullets. Okay, so we're in the right place now. So fire bullets, and it's going to take the number of bullets to shoot, the direction we're looking, the spread, and the distance they travel. So this is how you do a random number in QuakeC, called C random. And what we have is a variable called spread here that is passed in. And if you have the long barrel, it reduces spread, and if you have the short barrel, it widens the spread. So there's upgrades you can get that like control how much spread you have, basically. Um, and so what it's doing is it is randomly rolling a number from -1 to +1 and multiplying it times the spread factor times the direction to our right. And so every bullet is going to jitter a little bit left and right off center. It could come out straight too if you roll a 0 on C random. And then we also do the same for up. So we randomly jitter it up and down, we randomly jitter it left and right, and then we fire a bullet along those lines. Okay. So the code is exactly the same. That's kind of weird. Okay, so bullet trace line, Control-Shift-F, right there with the equal sign. Okay. So it does a trace line, okay, and it's going to try and hit everything. So this is what the code looks like, all right? So starting at the beginning, going to the end, hit anything along the way, and ignore ourselves. If we hit a goal, then it trace lines again, but ignores a solid. It only hits solid objects. And so the goal of this is to, this is kind of some weird specific code, but the goal of this is to be able to shoot corpses on the ground, I think. So by default, corpses can't be hit by things, and we wanted to be able to blow up corpses on the ground. So if you go up and you shoot a corpse with a shotgun, it'll gib. And so this is just kind of a big hack around that. But ultimately, what we're doing is we're just going to do a trace line from the beginning to the end. And then coming back down here, what the trace line function does is it sets a bunch of globals. It's bad coding design in the sense that it's bad. Like, you know, people wouldn't do it this way today, but I mean it works fine. Just be aware of the limitations. So when you call trace line, you pass in a beginning and an end and what kinds of things you want to hit and to ignore yourself. That's it. And then it sets all of these variables. These are global variables that get set by the engine. So the engine actually sets like a half dozen variables that are the results of the trace line. So in Unreal Engine, when you do a trace line, it gives you that hit structure, and that has like all those different things, like the name of the actor you hit, the point you hit, the bone that you hit, all that kind of stuff. All those are just set as globals in QuakeC, which I wouldn't do it myself, but it works. So, you know, you can't argue too much with success. You just can't do two trace lines at the same time. That's the main limit. Okay, so which, as it turns out, is kind of you can work around it. It's not a big deal. So if the trace fraction is not equal to 1, so trace fraction of 1 is exactly the same thing as in Unreal Engine. In Unreal Engine, when you do a trace, it will tell you the fraction along the line that the trace line went before it hit something. Okay, and so if the trace fraction is not equal to 1, that means we hit something, right? If we hit something immediately, it'll be close to 0. If we hit something near the end of the trace, it'll be like close to 1. But if it's 1, that means our bullet missed. And so don't draw a little puff of smoke if we missed, because that looks really weird, having puffs of smoke just appear midair, right? And so, and then it backs off the location that the puff is in is at trace _ end pause. That is the point of contact that the line hit. But it backs off 4 inches. And the reason for that is because if you don't do that, the puff will be drawn inside of the wall and it won't appear. And so what this does is it takes the ending point and it moves it towards the gun 4 inches, and then, or 4 units, whatever Quake units are, and then it will draw a puff, that little sparky thing there. Okay. And then there is a variable called trace entity. Trace fraction's not 1. Trace attack. Let's go follow the path down into it here. So trace attack, this much damage, this direction. Trace plane normal. So that's also something that's in Unreal as well. It'll give you the normal to the wall that you hit. So this is actually really useful if you want to do like a laser gun that like reflects laser beams off walls and things like that. You can do a trace line. When you hit a wall, it gives you the normal. The normal is the perpendicular vector. And then you can reflect the ray around the normal. And so you can have a chain lightning gun that you can shoot. You draw a line from here to here. It reflects off the normal. And then it goes from here to here. And then it reflects off. And so you can have a weapon that like you can bounce around, you know, corners and things like that. Just pretty cool. I haven't, I don't think I've written that code. Maybe I have at some point or another. But back like when Quake first came out, like a lot of people were playing around with that, having like weapons that could reflect off walls and things like that. I've written code that has like shrapnel that then bounces off the walls in a realistic fashion, stuff like that. Okay, so trace attack. So that's another one of those globals that gets set by trace line. And that is the perpendicular vector to the place you hit. Don't worry about that. Don't worry about that. Okay, trace entity. So trace entity, if you draw a vector through the world and you hit an actual person, that person is set to the trace entity. And let's see here, apply damage, event hit, not you. Let's go over to BB third person. I'm showing you the equivalent here. Okay, so here's trace line in Unreal Engine, right? These are all the different things that get set. So for example, the output hit normal. That's, you know, that. It's all the same thing, right? It's all the same thing. And blueprints are kind of like, they're pretty, they're graphical, they're visual. At the same time, like after a while, you're just like, oh Lord, look at all this spaghetti. And then like I always like, you see me when I'm making blueprints. I'm like always like cleaning things up, and then at some point I refactor things, put them into functions, and it's a constant struggle to like just keep blueprints organized in such a way that like it's not just like you know, this kind of like what is happening here kind of stuff, right? And I've not done a great job this semester in organizing the thing. I have put them into comments, and so you can click and drag the comment around, and all that code will just come with you. You know, if you drag the comment, the whole thing comes with you, like that. That's still not great. Anyhow, so here is the trace line, the line trace in Unreal Engine, and so it shows you things like the starting point, ending point. Let's see, where's the fraction? Time. That is the output hit time. They call it time, but it's actually the trace fraction. So it's a number from 0 to 1 that is how far along the trace line you were before the trace line hit something. And so if this number here is 1, that means your trace line missed. Right? True or false, did it hit something? That's the location that we hit something. That's also the location we hit something. What's the difference? I hit impact point. I don't know the differences between those. That's the normal. You can get how far away it is. So like how long the distance was until it hit something. If you hit something with a skeletal mesh, you can get the name of their bone that you hit, so you can do more damage if you do a headshot or an arm shot. So you can get the material on it, I think, somewhere in here. Yeah, there's the material. So you get the material, so like if you hit snow, then it makes a poof sound instead of hitting rock. There's a lot of things you can do with this. And basically, it's the same thing, you know, here. So you do a trace line, and then it just sets all of these values, and I'll show you all of them in 1 second. So let's look at trace plane normal, and that will be in def.qc right here. And then these are all the globals that are set by trace line. Okay. So trace fraction is again 0 to 1, how far along the line it got before it hit something. Trace in pause is the location that it hit. Plane normal is the normal of the spot that it hit. I don't know what that is. Trace entity is the person we hit. Did we hit water? That kind of stuff. And so when you do a trace line, it's basically just, you know, doing this, you know, without the bones and things like that, because QuakeC, Quake 1 originally did not have skeletal animations in it. So those things are not being set. But it's basically the same code, just in text format instead of graphical. format. You guys understand? So these globals here get set by traceline. And so when you do a traceline, come back over here. You do traceline. Trace attack. Bullet traceline. We do traceline, you give it a starting point, an ending point, you tell it what kinds of things you want to intersect, and ignore yourself. And then that sets those, it sets these values here. These are globals. Yep. Nunez, Cuevas, Tashler, you guys are going to have to do this over the weekend, so if you don't understand something, let me know now, because I will just keep going. I'll take your silence for understanding. And you can always look at other code, because that's the joy and beauty of modding. You're not given a blank file. You've got tons of example code. There's probably something in there already that does what you want to do. Okay. So that is like your typical hit scan weapon here. Matches over. All right. Just trying to find another map to play with one person in it. All right. Find. You missed the first lecture of this, you'll be behind. Okay, real fast, you have to download the Quake starter pack off the links off Discord and on Canvas. You extract it. You open it up inside of there somewhere. There's a source code directory. I think it's actually here for you guys. I put it inside of my source code directory here. Doesn't make much of a difference. You right-click on it, open it with VS Code. VS Code is a text editor. It's not Visual Studio. That's why I call it VS Code. It's really not Visual Studio. It's like a text editor. Then you want to come over to extensions, install the QuakeC extension to get context highlighting and things like that. The one by Victor Feitosa is great. And then you're good to go. And so all the files will be over here, and you can go to like weapons.qc, and most of the weapon code is inside of there. And then what you're going to do over the weekend is you are going to make a weapon. You're going to probably take one of the existing weapons. You don't have to modify any of the menus and stuff like that. You're going to take one of the existing weapons and make it cool. Okay? Just like how I took that rocket last time and shot it, and then it spawns a crucifix shape of rockets out of it. You're going to do something like that. You're just going to, maybe take the shotgun and make it shoot, I don't know, fire or something. I don't know, something cool. Like in Mad Max, right? The bass guitar that shoots fire out of it. So, this is called QuakeC. It's like the C language, it's different. So for example, this is how you define a function in QuakeC. That's the function name. These are the function parameters. That's the return type. That's just a QuakeC specific thing. That means we're defining the function. Any local variables inside of the function, you have to write the word local on it or it won't work. And then there's a bunch of like built-in functions, and that's kind of my lecture today, is like what kinds of things can you do in QuakeC, and what's the line of code to make it work. And that's what we're going over now. So you're caught up now. All right, Roberto, you cool? And my point is that there's basically the same things you do in Unreal Engine you do here. It just looks a little different. If you've never done coding before, then there's like all this text, and you're like, oh my gosh, there's text. This is not what I signed up for. I just want to make video games, man. But as it turns out, working with text is actually like a lot easier in a lot of ways than Blueprints. Blueprints has nice things about it, and I do like working in Blueprints. Like it does the type checking for you, which is really nice. Like you just, you can see this is green. This is green. That's a float. And if you try connecting like a float to something that's like an actor, it just is like, nope, can't convert a float to a thing. Nope, that works. What about that? Nope, that doesn't work. Okay, you understand? So Blueprints do like that type checking for you, which I really like. And it'll also do type conversion for you sometimes. Like if we get like the output hit actor here, and we like do like a print string. And you like connect the actor to the string. Normally that won't work, but it will actually grab the the name of the thing for you. So there's some little things like that that I really like about blueprint coding that I miss when I do like real coding with text. But by and large, like I vastly prefer coding in text than with blueprints. But blueprints are also easier for students as well. But my point is that it's really the same. It's really the same, and you just have to like you can't like come at this from a perspective like I need to learn everything in QuakeC to code anything. The perspective you should come in is I want to find something similar to what I want to do, and I'm going to take the code and manipulate the code and modify the code. That's the mindset. And when you do that, you start learning how games work on the inside. You learn how real programmers have made real games, and you learn the philosophy, and you learn things like the touch and think method of coding that just never occurred to me when I was in CSci at one classes where you just program it, right? It's all that stuff with like callbacks and stuff like that, and event handlers. Like, interesting. Cool. All right, so find. Sometimes you want to just find everything of one type in a game, right? Like let's say that you walk into a lever, and the lever like spawns bags of gold on the map for 30 seconds. It's like you pay $10 and it spawns all these things. You run around and gather them, and then maybe like you teleport away, and so like the normal timer stuff isn't going to work because there's like they're just going to wait for you to finish, but you've already left. And so sometimes like you have to like write code that's just like, okay, find every bag of gold in the world and just delete them. You guys understand? Like find every X in the world, find every demon in the world and kill it. Somebody casts the Holy Blade of Doom weapon that does 500 damage to every demon in the world. You call find, and you say find every demon and inflict 500 damage on them, which might not kill actually the shamblers and stuff in the game. So sometimes that happens. If you play on the rock map, when you release the poison, it does a find every player in the map and kill them with poison. So this is a very useful thing that we do a lot. You don't want to do it a lot because it's not great as far as like performance goes. But like in Unreal Engine, you could do like a find all objects by what's it called? Get all actors of class. And so this is how you do find in Unreal Engine, right? So you can say, give me all third-person characters in the game. Right? All right, give me all first-person projectiles. Right, so if I've been shooting my gun a lot, and then I'm going to go into a cutscene, I might want to just like delete all of the first-person projectiles in the game. So I could say, find all first-person projectiles. Then we'll do like a little for loop on this. For each loop, boom, and we're gonna say for every person in here, we're just gonna like remove it from. That's map remove. Destroy the actor. And so like this kind of stuff is pretty common, right? You're just like, okay, we're done with that part of the game. Phase one's over, so just go through and delete all the projectiles out, take the gun away from them, clean up. Pretty common thing to do. You guys with me on this? Do you understand this code in Unreal Engine? So find every first-person projectile in the world, and for each first-person projectile in the world, delete them. So this will delete all of the projectiles on the map. All right. And I don't know why I would be doing this here exactly. Where is this? And like click. Yeah, it's like if you left click. So this doesn't belong here, but like that code, that kind of code you write a lot. Samantha, makes sense? Find every projectile and delete it. Find every player and teleport them to the what is it called? And Samantha, have you ever played Among Us? You've never played it? All right. So this might not make any sense to you. Here. No, that's not it. Yeah, I mean that'll work, I guess. So like when you hit the button to call a conference, it teleports everybody into a room, right? So you would do something like find all players in the game and put them into the conference room. Or when a new map starts, you might want to move everybody out of the map and into this conference room or something like that. So you would do like a find all players and then drop them in here. Make sense? Among Us flashbacks? Yeah. That makes sense though? Like, if you're writing that code, you do a find. Okay. So find, let's see, where would we do a find in here? Let's find the find. Find target, t find, here we go. Print admins, it's not especially useful. Print to admins, not very useful. Let's see if we can find something fun. Some fun code in here. Find and damage, that sounds fun. All right. So, like when you change classes, right? So if you're the engineer and you change classes to be a medic, the game will detonate all of your buildings, right? Because otherwise, you could build a sentry gun and then become a medic and still have a sentry gun, right? And so when you switch classes, then it calls this function here, and then it goes and it calls find and damage all of your dispensers, all of your sentry guns, all of your Teslas, all of your cameras. For every building in the game, it detonates all of them. And that code looks like this. And so you pass in the type that you're going to search for. Like that would be like first-person projectile in our Unreal Engine example. And so it calls this function find. And it returns a entity. An entity is an actor. Okay. And if it can't find anything, it returns world. World is 0. So find, you start off by passing in 0 to it, essentially, and you give it the name of the thing you're looking for. I'm looking for sentry guns, and then it is going to, if you pass in, I don't remember what that was, 1? So what is that? Search entity self, check for ownership true, type 0. I don't remember what type is, but so type was 0, type was 1. Okay, so that's true. So while we have found things, if we're checking for ownership, if I'm the owner, blow it up. So what this code is saying is search for all sentry guns in the world, and it's going to return a list of all sentry guns, right? And then it checks to see if I'm the owner. If I'm the owner, then it blows it up. Otherwise, it only blows it up if depending on the flags set here. So if you don't check ownership, then type and don't do true. And then it calls find again. So this is kind of a weird setup. So what happens when you call find? It returns the first sentry gun in the world. And then you have to call it again to get the second sentry gun. And each time you call it, you pass in the last person that you found. And the reason why this works is because all of the actors in the world are in array. They're in an array of size like 512. And so you start off by passing in 0 world, and that's the first spot that it looks for. And then it just goes through the array saying, are you a sentry gun? Are you a sentry gun? Are you a sentry gun? Oh, you are. Okay. And then it returns the number 7. This entity thing here is really just an integer. It's just an index into this array of actors in the world. And so it returns 7. And then you can say, is the owner of entity 7 me? Then if so, blow it up. If not, don't. And then you call find again, and you pass in 7 this time. And then it starts looking at 8, and then 9, and then 10, and then 11, and then 12's 1. and then it returns 12 here. It loops. It's a while loop. So it keeps looping, keeps looping, and keeps looping until it can't find any more. And when it can't find any more, it returns 0, world. So when find can't find something, it returns 0. And so while 0 is false, it breaks the loop. If this was too complicated for you, just copy and paste the existing code. Right? I'm explaining how it works, but you just copy and paste the existing code. Like you just find existing code that says for every person in the world, kill them. For every demon in the world, kill them. You can just find existing code like this and then just modify it for your purposes. Okay. And so that's a way of looping through all things of one type in the world. It's not especially efficient. It's also not especially slow either. You don't want to do it necessarily, all the time, but if you do it some of the time, you're not going to break the bank, right? Because it's just it's going really through every object in your world. And so if you've got 10,000 things in your world, it's going to go through 10,000 of them, and that's not fast, right? So use with reason. Like, when a person dies and they respawn as a medic, that happens like one time every 10 minutes. It's not a big deal. But if you're doing it every frame, you should probably rethink your life decisions. Okay. So find just searches for everything on the server. If you want to find things within a certain point, there is a function called find radius. So find radius is how you do grenades and things like that. So find radius will give you everybody within, 10 meters within a target. Okay. So find radius is useful for rocket launchers and grenades, any sort of radial damage. We use find radius for, and then we do damage with it. Although actually I think there's a function that does the radial damage here. So let's do like grenade. And let's see if we can find a place where flare grenade touch, that doesn't do any damage. Grenade explode. Grenade explode. There. So that function right there, radius damage, that is our function that if you just are doing a find radius, search, a search of everybody within it, just to do damage to them, don't worry about it. You want to do T radius damage instead. Okay, if all you want is to do radial damage, there's a function for that, T radius damage, and you pass in yourself. You're the grenade, the owner of the grenade, how much damage it does. The damage is equal to the radius size also. So the bigger the damage, the bigger the radius that it does, and it has damage fall off and all that stuff built into it. So if all you want to do with your find everybody near me thing is damage them, you use this function. Okay? And don't do damage to the world, I think. That's what that means. And so that's how you do radial damage. If you want to do, if you just want to like find everybody near you, then that's called find radius. And this works just like the find function, except it has a point and a radius, a range on it. Okay. So for example, here, place is my location. Radius is let's find a better one here. Crusader. Okay. Spell. Okay. So this is a ability that does damage to all demons within 1,000 inches, however big that is. And so when you hit dispel, it does a find radius. And the reason why we're doing this instead of the radial damage is because it is only going to... It has some weird special rules on it. So it's going to find everybody within 1,000 feet of this point. 1,000 feet, sorry, 1,000 inches of this point here. And then the loop is exactly the same while it does not return world. Then it's going to do some stuff. And then at the very bottom, you say T equals T chain. So it's actually a linked list that it creates. It creates a linked list, if you know what that is. If not, just copy and paste the code. It'll work fine. So find radius actually creates a list of results. And you just iterate down the results like this. And that'll give you a list of every person who is within 1,000 units of the origin. and then you can do things with it. Like, for example, if the person within the radius is a player, and their health is over 100, or over 0, sorry, and they're a warlock, warlocks can actually take damage from being dispelled. So, if it's a monster, but not an army, then it takes 300 to 600 damage. If they're a warlock, warlocks can be dispelled as well, and they take 25 damage. Not a lot, but they take 25 damage. So if you're a crusader and you dispel evil, then all the monsters take huge amounts of damage, but warlocks take a small amount. That's why we couldn't use your standard grenade, explosion thing, right? It has a fixed origin. It has a fixed origin, fixed radius. Does everything. Just does flat damage within it. There's no damage fall off, and there's special rules for like if it's a demon versus a warlock and things like that. So the normal grenade code just doesn't work with it. Shambler, Christmas range. This is Christmas code. That's funny. So let's see here. So it's going to find everybody within its Christmas range, whatever that is. And while it's not the world, then I don't know what this is doing. I didn't write this code. What about this? Cool push. Okay. So this is a weapon that it's kind of a weird weapon. So the dataless cannon, it looks like a rocket launcher, but it behaves kind of weird. So what it does is when it hits, it does a find radius. It finds everything within this radius of us, whatever that is, 140. So everything within about 10 feet, it's going to find. And then if the thing can take damage and it's not a building and it has health, then it takes... No, we push it, actually. So this code here is actually going to knock the person. So if the person can take damage... So if you shoot somebody with this weapon, it actually sends them flying. It's like a concussion grenade. It actually launches them through the air. So if you hit them with it, then it messes with their velocity. So basically it takes their velocity and kicks them through the air. So you can juggle people essentially with the weapon. So whatever their velocity was before, if it was below 200, their Z velocity, their upward velocity is now 200. So when you shoot somebody, it kicks them into the air. And then there's more. This is all linear algebra, figuring out what direction you should punch them in when you hit them. If they can take damage, if they're building, then they take 100 damage. And what's notable about this is does this code go through a wall? What do you guys think? Nunez, Cuevas, Tashler, Ramirez, what do you think? We're finding everything within 10 feet of a point, and then we're saying if it's a building, do 100 damage to it. Does this mean the weapon can damage sentry guns on the backside of a wall? Perchance. Probably. I would hope not. Do you see any trace lines in here? Do you see anything here where it's trying to see if there's an open line of sight between it and the target? Depends. Do you see any trace lines in here? Anywhere? You can ignore all this stuff. This stuff is like the thing that kicks them. So it's just basically saying find everybody within 10 feet. If they're building, deal 100 damage to them. Nope. Nope. You don't need a small crack. This weapon will actually damage buildings through walls. That's what it's for. So the weapon doesn't do a lot of damage. It's mostly an annoyance against players because you can like bat them around the map, right? This thing here, like you kick them around. It doesn't do very much damage to players. It does 40 damage. It's a very weak rocket launcher. It's a very slow rocket launcher. It's a very weak rocket launcher. What its purpose is this. And so basically, if you know that somebody has built a sentry gun up against a wall, you shoot the Daedalus into the backside of the wall, and it breaks the sentry gun through it. And so it allows you to work against like heavily entrenched positions, because sometimes people will like super fortify like a choke point, and they'll build a force field on the backside of a doorway, and you can't shoot the force field because it's on the backside of a wall. And so the Daedalus cannon is a counter to that strategy. It's not a great weapon, but it is a very effective weapon at defeating a turtling strategy. So when people turtle too much, the game's not fun. And so basically people will pick up the Daedalus and blow up things through walls. It's not a big radius. Like 10 feet's actually not, it's 3 yards. Like that's not really that deep into a room. You can break it through a wall. But when people have like super fortified up against a wall, then you can break things through the wall, and that's the point of the weapon. If you hit a player, they take so it strips off 40 points of armor from them, and then it does balance minus points. So half the length. 40 minus. Okay. So let's say there's 60. Let's say there's 60. So they're 5 feet away. They're 5 feet away out of the 12 or whatever that it shoots. 60 minus 40. So 60 divided by 2 is 30. So it's 110. 110 divided by 8 damage. So this thing does like 15 damage. Like it does almost no damage whatsoever. It is an exceptionally weak weapon. It does strip their armor though. So it will take 40 points of armor off, and then it'll do like 15 damage to them, 10 damage to them. It's a very weak weapon. The goal though is to strip their armor off, and after you've stripped their armor off, then it will do like 40 points per rocket, which is still way, way worse than like the 120 or a normal rocket launcher does. It's really there to like destroy people's armor. So some people will buy a lot of armor, and so this weapon is really good at just ripping their armor off, and then they don't have special armors because people will buy special armors that protect them from like snipers and things like that. And so you can do this to destroy their armor. It's an anti-armor strategy. It's an anti-armor weapon. It's an anti-building weapon, and it's a concussive weapon that is really good for knocking people around, and it can also knock yourself around. If you jump and you shoot the ground, it will kick you through the world really fast, and it doesn't do a lot of damage. So a lot of people use it as a mobility device. So they will run through the world, jump, shoot the ground, and then fly right with it. And so it's actually used for like rocket launching, and deliberately so. And so it's oftentimes better to shoot yourself with it than to shoot other people with it. You have the flag, you jump, shoot the ground, it'll kick you through the world carrying the flag. Whee! You get away from people. So it's kind of a weird weapon. I think it's still on the weak side. Like I think that honestly, it's just not worth the money right now. But it is a very specific counter to several very specific strategies. So I haven't changed it because if you made it stronger, then you would get those counters in addition to having just a good weapon. So probably if I were to do another pass on this, I'd probably up the damage a little bit, so at least you can do a little PvP with it. It is the slowest rocket launcher. Like it comes out slow, and so people just dodge it. Like people don't even get hit by it usually. So okay, but that shows you find radius. So find radius is just going to give you a list of everybody within almost 12 feet. And then it just goes head equals head dot chain, and it'll just sit there and run through all the people. So every person, every building within 10 feet, 12 feet is going to have its armor destroyed, be kicked, and if it's a building, be taking a lot of damage. And that, my friends, is that. That's basically the 5 tools you need to interact with the world. That's really all you need to make anything in a game. And you're like, but there's got to be more than that. And there's like some linear algebra stuff you could do and things like that. But really, this is all you really need to make an interactive game. Like think about StarCraft. You like click on a unit, right? You can drop a trace line from the camera down and see what you hit. Oh, I hit this Protoss. It's selected now, right? Really, with these 5 things, you can really kind of code anything, and all these things exist in Unreal as well as Quake. So I have a little cheat sheet for you all here that kind of shows you like how to do things in QuakeC versus Unreal Engine. If you want to play a sound, you have to first pre-cache it, then play it. So if you want to see what that looks like, again, you know, you don't need to memorize anything. You don't need to like take notes and things like that. What you need to do is be like, all right, I want to play a new sound. I want to make it so that when I shoot the gun, it plays carnival music or something, right? How do I do that? Well, what you do is you find existing code that does that already, you know, and then let's quit out of this. And what you do is you find code that does it already, you know, and then copy and paste it. So if you wanted to add music to your thing, first of all, inside of the Fortress directory, there's a folder called Sound. That's traditionally where people put all the different sounds and things like that. But in the source code, right-click, open in with code. I've given you, that's why I have this cheat sheet here, because you might not know what it's named, right? So I'm giving you the names of things so you can look for it. So the first thing you have to do is pre-cache sound. Okay, what does that mean? Where do I go for that? So you go to search, search for pre-cache sound. And there's a lot of these things that are pre-cached. Okay, I'm just going to click on, I don't know, one for rocket launcher or something. It is a very helpful sheet. This is why I'm a professor. I like helping people. So let's go over, I don't know, Gib, why not? Okay, so you can see that there's just all these functions, and all of them are just pre-caching sounds. And so what that means is that when you load the level, all these sounds are loaded off disk, so you don't have to pause to play the sound because it has to load it from disk. So, you know, if you make your own wave file, you can just like copy, paste, and call this one kearney.wave. And then inside of the directory here, inside of sound, and see this says the player directory. Okay. Inside of the player directory, you can create a file here called kearney.sound. And then kearney.sound is now pre-cached. Okay. Because I put that line right there. Do you see? Like, you just copy and paste existing stuff, you know? Don't try learning everything. Like, this is the mindset of modding. You find stuff that's in there, you copy and paste it. Cool. Kearney.wave is now pre-cached. All right, how do I play it? Let's come back over here. You can play a sound with sound. Okay. So let me delete this because I don't actually have a Kearney.wave. So yeah, let's just see wherever that guy is. Elburn, when, one.wave. Okay. So here. So this is how you play a sound. Okay. So there's a function called sound, self, voice channel. That's the wave file to play. That's the volume, I think. And that's the attenuation. And so you just find a sound that's kind of like if you're trying to make new bullet sounds, then you find the wave files for bullets. You know, they're probably on a different channel. They're probably not on the voice channel. You know, like maybe search for sound. And let's see if we can find rocket sound or something. Thunder, menu, site, enemy, slime, pimple. Let's see here. Sure, why not? Okay, so this sound function, it's going to have, oh, and the first parameter to sound is the locate. It's the entity the sound's going to come out of. Okay, so this is if you do a trace line. It's going to come out of the thing that you did the trace line on. It's going to come out of the weapon channel. It's going to play that wave file, full volume, normal attenuation. And so it plays the sound in the world over there somewhere. We must have done a trace line. Trace line. Up here, there's a trace line. Okay. So we do a trace line from our location to our location plus forward 64 units. So it's doing a trace line about 5 feet ahead of us. And if we missed, we skip. And so basically coming down here, if we hit a player, then it plays this sound. If heal him. Oh, okay. Oh, okay. All right. So if we're using the spanner and we hit a teammate, then we heal them. Okay. So this is playing the armor pickup sound or something like that. So if you hit a teammate, then it's going to play the sound on them that you're fixing their armor. So this is like Torbjorn from Overwatch. I know they changed how his armor worked, but basically the engineer in Team Fortress can repair other people's armor. And so when you do so, it plays this sound. And so you can just look at it. You're just like, okay, that's how you play sound. Cool. Neat. Okay. Play sound, change the model that something has. You pre-cache the model, then you set model. It's the same thing as this. Just find existing examples and copy paste. Trace line, I've gone over. You do a trace line, and then in Unreal, right? This column here is how you do it in Unreal, right? You do line trace, and it's basically the same thing, except it's line trace instead of trace line. Radius search, find radius, multi-sphere trace by channel. Spawn entity, spawn actor. Destroy, de-remove versus destroy actor. Get the forward vector. It's very similar stuff. Change position, you set the origin versus set world location. Change velocity, set velocity, change angles, change your world location. So there's this cheat sheet here that I'll put up in the modules section for you on Canvas. And it basically just shows you every possible thing that you might, maybe not every possible thing, but like every possible thing that you want to do ever in a video game. I've got the function name for it. And, if you want to do particles like Niagara, right? Over here, there's only 14 particle effects baked into to Quake. Total. There's just 14 hard-coded particle effects ever that you can use. And so you have to squeeze a lot of juice out of that stone to do anything interesting with particle effects. Unreal obviously has a much better particle effect system with Niagara. Animations, collisions, touching, timers, basically everything you want to do is in here. So let's talk about your homework assignment. So your homework assignment is to do something cool with the weapons in Quake. I want you to modify a weapon in Quake to make it cool, make it cocky, all right? Make it shoot fire from your lips. I don't know. Like, you shoot the shotgun and bolts of lightning fly out, right? All of that, there's code for all of that already in there. You just have to find it and merge it together. All right, there's already code to do lightning in the game. Just make it so that when you click the shotgun, lightning flies out or fire comes out, or when you click the shotgun, it damages everybody around you with like a radial damage or something like that. So your shotgun explodes when you click or something like that. Just something cool. Okay, you guys have till Tuesday to do this. I don't expect you to know QuakeC. Okay, I'm giving you this assignment to code a weapon with only sort of this peripheral introduction to QuakeC for a reason. And the reason for that is because the skill I'm trying to develop in you is your ability to find things done already and remix them without understanding them necessarily fully, completely. Right? This is something that a lot of students are afraid of. A lot of students are afraid to experiment and to try things, not fully understanding them. And I want you to get out of that mindset and get into the mindset of playing with code. Like, let's just try it. We got this particle effect code here that does lightning. I'm going to try bringing it over. I'm not sure what this variable does. I think it should be here or something. I don't know. I'm going to put it in. And if you get stuck, message me. I'm here to help. That's why I'm a professor. I'm here to help you guys. I'm not here to, give you impossible assignments. But I want you to have that feeling of experimentation and fun and taking pieces and putting them together and things like that. And just seeing how they work and see if you can come up with something cool. All right. So this is also really the first coding assignment you've had this entire semester, I think. We worked a little bit with the QuakeC code before, but not actually doing anything. So if you've never done coding before, again, I'm not expecting you to know anything. Just find things that, use that Control-Shift-F, find things in there, and, try making it work. Start small, start with something small, and then just kind of build up to something cool. And if you don't remember how to compile your code, I'll go over that one more time. So release, Fortress, source code, open in VS Code. So if you, I don't know, change something, so like, I don't know, so we change this or something like that. Hit save, go into your source code directory, hit make. When you compile it, this is what it'll look like if it worked correctly. And then you just go up and you rerun the server, or if the server's already open, then if the server's already open, then all you have to do is change the map, and then your new mod is loaded. That's the steps. That's the workflow. You change something in VS Code, hit save, make to build it, and then reload the map in the server, and you're good to go. And you can just sit there and iterate and iterate and iterate as many times as you want until you got like a cool shotgun or a cool rocket launcher that shoots laser beams, or, you know, a shotgun that fires a ring of fire, or rockets that fly in every direction. Whatever you want to do, just something. All right. So that is our class for today. Thank you for coming out. I'm going to be available all weekend for help on this. But again, just start early. Just play with it, see what you got, and have fun. And I'm going to put this under the modding category. So this is actually going to be worth far more points than your normal daily work. So don't be like, this seems hard, I'm not going to do it. This is going to be a huge impact on your rate if you don't do it. So that's it. Thanks, everyone. Peace out.